Design of underground excavation and pillars. Design of underground excavation and pillars. So today, this is more or less more of underground, okay, underground stuff. And so we have realized that when we are working in the surface mine, we have the sky as our roof. And so we worry not unless it is raining. We have that flexibility to do all that we want to in terms of equipment usage and whatnot. The restrictions are minimal. But then when we come to underground, we are restricted in several forms, and even more to the point, the fact that we are using part of the rock as our roof, there is that need that we ensure some kind of support, or the rock is stable enough till the time that we are going to be in there working or actively doing something. And so today we want to look at rock support system. So a piece of rock becomes loosened. If a piece of rock is loosened, that particular rock is no longer capable of providing its own support. So we have already stated that the rock is, as in its normal state, has got some kind of body forces within that have distributed within the rock mass or the intact rock mass. And this is what is causing it to be stable. So as soon as you undertake any activity within it, you distort that equilibrium state of the forces. And so they begin to give you issues, which is that instability. And we realized in the slope analysis, what are some of the issues we can encounter if we happen to create slopes, and the instability we incur, the type of instability we get in there, and how we can resolve them. In the same way, when we create anything like opening or separation or any rotation within the rock too, the strength is also again distorted, because the interlocking blocks that are causing the stability are they are now in disarray. And so you have to make sure you find another means possible to bring about that support. And so all right, so we have underground excavation. Good. So we are saying that if the rock is loosened, all right, so if a rock becomes loosened, it's no longer capable of contributing to its own strength. And so any activity such as opening, separation, or rotation we do will destroy, this is the key word, will destroy the strength due to the interlocking inherent in even the most extensively disjoint or jointed rock mass. So the stability and safety of an excavation in rock is determined in the first place by the extent to which these disruptive elements are prevented. So when we get to any mining activity, when we are talking, for example, the underground operations, as soon as we mention the word stability and then that of safety, what we are interested in is to bring about prevention of anything that has dire consequence on us, or if possible, the second thing is, if we cannot prevent it and it happens, we try to bring about control measures. So these key things are what we look out for, either to bring about prevention or to bring about control. So these are the things we do when we talk about safety and that of stability underground. Then we say the term support is widely used to describe the procedures and then the materials we use to improve the stability, which is going to bring about this control and that of the prevention. So these two things is what we are bringing in the support to help with. And so, and then maintain the load carrying capability. So when I bring in the support, It is going to enhance the load carrying capability of the rock near the boundaries of an underground excavation. So the rational design of support system must take into account the infrastructure nature of the load, deformation characteristics, and the rock and support system. So for example, I want to design a support for an underground stove. What do I need to consider? The main idea here is that I have to first look out for the load deformation properties. That particular material that I want to support, how does it behave? Is it having some kind of tensile strength? What kind of failure is even occurring within the material? So I need to understand these properties of the formation. When I understand them, then what then can I use as the support? So the type of material I'm going to use as the support, I have to also understand the properties and characteristics that surrounds this support system. So if I get to understand the material the support is going to carry, then I'll be able to tell whether I should use wood for the support or I should use concrete steel. Okay, I should use steel for the support or concrete for the support, or even rock bolting. Will it do the action? So I have to understand this. Then I have the primary objective of a support practice are to mobilize and conserve the inherent strength, because we said that the rock already has got some kind of strength within. So if we are bringing a support system, it is to conserve this strength that already exists within the rock. But then due to our own action, this strength is compromised. And so if we are bringing in support, that is the main objective of the support system, so that the rock mass becomes self-supporting. That is the main objective of implementing support systems. So the support system provides the structural elements which carry the whole part or the weight of the individual blocks affected by discontinuities or of zones of loosened rock. So if I'm bringing in support, there are two things. It is either the support system I am bringing is to support a section of a whole block, a section of the block, or the whole block, or certain places that have got discontinuities is what I'm concerned about, which I want to provide the support for. So you have, that is what the support system is going to provide, whether it is going to help carry the entire load or an aspect of that load. And that will be dependent on how much harm we have caused the strength of the rock. So supports for permanent excavations are usually termed as primary or secondary. So we have primary is implied during or immediately. For example, I want to create a tunnel. I want to create a tunnel. So that tunnel I'm creating, at the point where I'm creating that tunnel, I am having issues in terms of stability. So I need to bring in support immediately so that I can continue to work. So whilst I am bringing in that kind of support I need immediately to undertake my activity is what we call the primary support. So primary support is applied during or immediately after excavation to ensure safe working conditions during subsequent excavation, and to initiate process of mobilizing and conserving the rock mass strength by controlling the boundary displacement. So I am doing the excavation, or I have brought about some kind of excavation, and I could sense some instability within the walls. So immediately I put in measures that can help maintain the stability of where I am working for safety of man and machinery. Then we also have additional support that we can bring in later. So this type of support we are bringing in later, we call that the secondary. It means that as of the time we are working, we didn't need that immediately. We could go about all our activities. but having it at the back of our mind that we need to provide support just in case. And so that type of support is the secondary. And again, these support systems can be classified as either active or passive. So we say a support system is active when it deals directly with the rock. For example, I have rock bolting, because this type of support I am providing is going to be part of the rock. It is going to be drilled within the rock just to hold certain disjointed rock or two planes together to facilitate the stability I want to ensure, and then proceed with my activity. So that type of support, we call that the active support. And a passive one is where I install some kind of steel works within an excavated zone that more or less is not directly within the rock, but around just the surface of the rock, so that in case there's any rock fall, that thing traps it. Then we call that the passive support, because that type of support is not interacting directly with the rock mass.